Hello YouTube, this is Dr. Ronald W. Satz, founder and chair of the International Society of Unified Science and president of TransPower Corporation, a commercial custom software manufacturing and certified systems engineering company. I work as a theoretical physicist and as a systems and mechanical engineer. I also work as a theoretical economist and as an operations researcher. Today's screencast, we will be continuing with Optimal Economist and implementation of Larsonian Econophysics. My theoretical physics mentor, Julie B. Larson, was also my theoretical economics mentor. What I've done with all of his work, both his physical science work and his economics work, is to make everything computational and easy to use. So hence the Optimal Economist software program. In previous screencasts, I've already covered microeconomics of individuals and companies and business sectors and their associated graphs, and I've covered the first layout for macroeconomics of countries or regions. So I'm going to click there. Yeah, this is kind of busy, I know. I'm going to just make this a little bit larger if I can. Okay, just move this back. Just this window just a little bit. There we go. Move this down. Okay. I've covered these fields last week, so I'm going to click on the country info 2 layout. It's a little bit less busy. Now, of course, if your country is different from the United States, you would put in your own data. Now, look, this is a simulation of whole countries or regions. So there is a lot of data you have to put in. That's just the way it is, but I've kept it to 2 layouts. So anyway, all this is copied from, the first layout. The region or country name is here, count code. I put in the Federal Reserve chair here. For your country, you'd put in the central bank chair if you want. And then I have these ratios: return to capital decimal 0.3, return to labor 0.7, depreciation rate 0.066, which seems to be normal. We're considering 11 past points and 5 future points, and the number of poles is 4. That's an advanced setting, just don't worry about it. So this is from 2005 to 2015 and then a 5-year projection. So it's already 2020. The program has been out for a year or so now. So anyway, the fields are here. This is the let's get this straight here. The observed values of capacity utilization assumed to be the same for both goods and services. Okay. ZP. This is these are the ratios. Observed C-res plus 1 divided by observed Y plus 1. So it's kind of a ratio. The program commutes that for you, so you don't have to worry about it. Incidentally, to really understand the fields and so on, before you obtain or purchase this program, please read my free paper, which is available on the web. It's called Theory of Microeconomics and Macroeconomics, Larsonian Econophysics. So it's a little bit more than 100 pages long. It's also part 3 of my very, very comprehensive work called Existence and Interactions, a Computational Treatise of the Reciprocal System, the True Theory of Everything. It's part 3. But you can read this paper for free online. Alright. So, these are the ratios in this projecting one. It represents the combined effect of a change. I got to read the tooltip myself, of a change in capacity utilization and change in the consumer purchasing power stream. Okay? This is the velocity of circulation of the currency based on M0. We use M0, that's hard currency. And you can see how the velocity has dropped over time here. And then GDP, this is the observed past values of GDP in scientific notation, okay? Just so I can fit everything on the screen, we use scientific notation where it's a large number. This is the observed growth rate. Okie doke. This would be the calculated values of future GDP based on mean values of all the different factors. C-res, AVOL, FV, and delta. So that's down here. And that would then be the growth. Should be a little bit different than what you see here. This is the total national taxes paid in scientific notation. This is the calculated decimal effective rental price of capital, which is pretty high, but that's the actual value, not the phony artificial interest rates of the Federal Reserve. And these are the calculated decimal effective rental price of capital, subtracting out taxes, depreciation, and inflation. So that's really the true rate here, and you can see, wow, kind of a drop. Income B is the investment income. These are added to wages to make the total employee income, which is on the first layout. All these columns here represent the future projections here. So now continue with the past value. These are the observed values of inflation rate in percent. This is CPI observed, which is cumulative from the base year. This is the ratio of the value of G effective, the part of the change in M0, which actually gets into the purchasing power stream to the values of G calculated from the change in M0. Okay? That's kind of interesting. So just because the Fed changes G, changes the amount it injects or takes out of the money supply, I mean, it doesn't actually necessarily get into the purchasing power stream of the consumers. That's extremely important to understand. A lot of that also has to do with velocity, but if the money is stuck in the bank and doesn't get into the purchasing power stream, then that really has no effect. So just keep that in mind. These are the calculated decimal changes in the monetary base to obtain 0% inflation. That would be ideal. Not this phony 2% inflation that the Fed wants. And then the optimal one, as far as I'm concerned, is the calculated decimal changes in the monetary base to obtain a 1% deflation or minus 1% inflation. Okay? That's what I would prefer. I'm going to turn off the phone here. Okay. I don't know about you, but I get bogus calls all day long. It's really quite annoying. Here's the change in the velocity of circulation using the GM0. Here's the change in velocity of circulation based on the effective G. And then this is capital G divided by GDP. So these are the ratios of government expenditures to the observed GDP. Okay, and then these are the ratios of imports to GDP observed, and these are the ratios of the exports to GDP observed. Okay, and then all these below here are projections. So I'm not going to read the whole note here, but I do say, so most of the change in M0 in 2009 stayed in the banks. So this is why it's better to calculate the effective value of the change in M0, which is G effective displayed on the continuous for one layout, and use the change in M0 directly. Okay? Alright, well, that's a lot to take in today. That covers the total simulation of a country like the U.S. You can add a new record here, put in your own country's data. If you're a professional economist and you're working for the central bank of your country, then you'll have easy access to the data you need to put in. But really, it's only just two layouts, so it's not that bad. But you got to have all this information and do a real analysis. So the original price for this program was $295, but given the recession/depression we're in because of the pandemic and the government shutdown, we've reduced the price to a mere $95. That still includes free email support for the life of the program, so it's quite a deal. There's nothing like this on the market. But please read my paper, Theory of Macroeconomics and Macroeconomics, Larsonian Econophysics first, and then purchase the program, and we'll help you with any support we can with it. All right, that's all for now. But next week we'll look at the graphs, which is what everybody likes to see. Thanks for your attention. I'm going to close out of here. I'm going to hit close, back to the main menu, and we're done.